Good day, viewers. Welcome back to Networking E10. Now that we have understood data encapsulation and data decapsulation within the TCP/IP model, it's time to understand how it actually works in the real world. Today, we will see what happens when a user tries to access a website. We learnt in the previous video how HTTP, TCP, IP, and Ethernet headers were encapsulated to the payload message, "Hello there," in the transmitting device. This message was later decapsulated at each layer of the TCP/IP in the receiving device to receive the final payload text, which was "Hello there." On similar lines, let's take a real-world case where one machine can send or receive data from another machine. For example, accessing website data, booking tickets, online money transfer, playing games, sending and receiving emails. We will use one of these examples to see the TCP/IP protocol suite in action. In this video, we see that Bobby, who's located in Japan, wants to access a ticketing web server which is located in Africa. The owner of the server in Africa is Smith. Let us name the ticketing server URL as www.smithsticketing.com. The first thing Bobby needs to do is to check if his PC has an IP address. It could be manually or dynamically assigned IP address. Once the IP address is assigned, then Bobby needs to open the browser on his device and then punch in the URL www.smithsticketing.com. This URL is input by Bobby at the application layer. Networking devices do not understand URLs. Instead, they understand IP address. Therefore, we need to first resolve the URL into an IP address. In this case, we need to resolve www.smithsticketing.com to an equivalent IP address. This process is called DNS resolution and is achieved using the DNS server. It is also known as Domain Name Subsystem Server. Additionally, if the user knows the IP address of the destination machine, DNS resolution is not needed. In the next videos, we will understand how the URL is resolved into an IP address and stored in the DNS cache. Since Bobby is trying to access the URL www.smithsticketing.com, Bobby's machine needs to retrieve the web page first and later perform the ticket booking. So let's get started with the web page fetching. At the application layer, Bobby's machine starts with HTTP encapsulation using one of the HTTP methods, which is named as GET. The GET method is used because the ticketing web page needs to be requested from Smith's machine and then displayed on Bobby's machine. We will discuss about HTTP methods in the next upcoming videos. Next, the HTTP encapsulated message is further encapsulated using the TCP header at the transport layer, followed by encapsulation using the IP header at the Internet layer. We will discuss in detail about HTTP header, TCP header, and IP header in the next videos. We need to recall the IP which was received as part of the DNS resolution and placed in the DNS cache. This same IP will be used as the destination IP inside the IP header. This will be clarified when we discuss IP header in detail. At the Internet layer, we spoke about IP header. Now, I would like to introduce to you another protocol named as the Address Resolution Protocol, or ARP, which operates at the Internet layer. We do know the destination IP address, but we do not know the hardware address or MAC address of the destination machine. This is where we understand how ARP helps to get the destination machine's MAC address. This destination MAC address is saved in the ARP cache and will eventually be used to populate the destination hardware address field of the Ethernet header at the network access layer. Basically, there were two queries done by Bobby's machine. First one was DNS resolution to get the destination IP address to be populated in the IP header. Secondly, once the destination IP address was identified, the destination MAC address can be fetched using ARP protocol. We will discuss ARP protocol in depth in the upcoming videos. One thing to note here is that Bobby's machine may or may not perform the ARP process based on three factors. 1. Firstly, no ARP will be done if the ARP cache has an existing entry containing the destination IP address and its equivalent MAC address. 2. ARP will be done if the destination IP address is in same subnet as Bobby's IP address. In this case, the destination machine which is in same subnet will respond with its MAC address. 3. ARP will be done if the destination IP address belongs to different subnet. In this case, the wireless router's MAC address will be returned to populate the ARP cache of Bobby's machine. Next, at the network access layer, the Ethernet header and trailer is encapsulated to the packet received from the Internet layer. Note that the destination MAC address which is populated in the Ethernet header is wireless router's MAC address picked up from the ARP cache. We will understand the Ethernet header in detail in the upcoming videos. Finally, the bit stream is translated to electrical signals and transmitted over the LAN cable, which is the physical medium of data transmission in this particular case. There is another transmission medium which is also shown here, that is the wireless medium. The smartphone connects to the wireless router using this wireless medium. Once the data is received by the wireless router, decapsulation takes place at the network access and Internet layer. Decapsulation cannot occur at transport layer in this case, since the router operates at Internet layer, like we discussed in the earlier videos. After the decapsulation process is completed in the wireless router, another encapsulation process starts, but this time the source IP address is modified. The source IP address would be the WAN IP address of the wireless router, and destination IP address remains unchanged. The destination IP, as we know, is the IP fetched as part of DNS resolution process. Note that routers have two interfaces. Ideally, one being the LAN interface facing smartphone and Bobby's machine, and the other being the WAN interface facing the Internet service provider. Private IPs are assigned to LAN interface and public IPs are assigned to WAN interface. The data then gets forwarded to the Internet service provider and finally proceeds towards Smith's network with the help of the destination IP address, which was received as part of the DNS resolution. Please note that destination IP being discussed is a public IP. We will talk about public IP and private IP in next videos. Once the data reaches Smith's router, decapsulation occurs till the Internet layer. Post that, encapsulation is done by modifying the source IP and destination IP. The source IP will be the router's LAN IP, and destination IP would be the IP of the ticket booking server. At the network access layer of the router, the destination MAC address would be the MAC address of the Layer 2 switch, which is shown. The data will then get forwarded to the Layer 2 switch, where encapsulation and decapsulation would happen at network access layer only. Once that is completed, the data is forwarded to the ticket booking server. The decapsulation process would occur once again at the network access layer, followed by the Internet layer, and then the transport layer, and finally reaches the application layer. Since this was a HTTP GET method, which was requested by Bobby's machine, the ticket web page content will be returned as part of the 200 OK response of HTTP. This 200 OK response data will travel down the same path through which it arrived. Once the 200 OK response content is received on Bobby's machine, he can view the ticket booking web page. Bobby can then enter the booking details and confirm the booking. Hope this video clarifies how TCP IP protocol works in real world. We have used ticket booking system as an example for understanding TCP IP. Based on real-world applications, we could use different application layer protocols to perform different operations, but the underlying framework for data transmission remains the same as what we discussed in today's video. Thank you, friends. Have a nice day.